What's up, you absolutely wonderful Magento 11 friends of mine? Joseph here with another practice test question for the third try here. Anyways, so this one is a good question. It actually exposes an area of Magento that you probably don't touch that much. And so on the surface, it seems like a fairly simple problem, but each one of these answers has very deep implications as far as how these are lived out. As such, I challenge you to work through this question and answer with me as we explore how this works out in the end. A merchant has asked you to exchange the encryption key for a Magento website. However, they are concerned that this will cause disruption to the purchase experience and specifically their payment credentials. Which two statements explain the process to the merchant? Jumping ahead, the new key is stored alongside the old keys. The developer has to run a command to update all customer hashes, password hashes. Store configuration values are re-encrypted with the new key. And finally, all caches must be flushed immediately after said change. So what is the answer on this one? Well, it's actually not as difficult as you would think, and I would like to walk you through what this process looks like. When you save a new encryption key, that actually is saved into env.php. And we already had one set here, which ironically speaking was already set in config.php. Now, this is included in our sample project for Art of E-commerce debugging. This key has already been set for the ease of getting your environment up to speed. Now, what you'll notice here is a great demonstration of deployment config. This has already been set for the original value, or it's been set in config.php, but env.php actually overwrites it. So that's how there's basically an array merge. Look it up in deployment config. So when I created a new one, this value was already loaded in, and then it added this new value on top of that. It generated and added it on top of that. So what actually happens in this process of creating a new key? Well, this happens in the change class, and the specific file name is, you guessed it, change encryption key. So a couple of things that happen. First, it checks if this is writable. Now, one thing that's very important with this is you can use environment variables, which I would argue is significantly more secure than the file system. Keep that in mind for best security practices. Now, if there's no key specified, it's going to get a random key. Now, let's take a look at this method, this encryptor set new key. This method has 4 lines? Pretty simple, but there's something very important. It adds this key to an array of keys, and then it changes the key version. Well, where does this come from? Let's jump to the top into our constructor. We see this keys is loaded in from the deployment config, and it splits it up based off of a pattern of white space. The key version is the last of this list. So now we piece this together, come back to our env.php. It takes these values here when it is loading up for the first time, and it blows these apart. And the key to be used for encryption and decryption is here at the end. And I should qualify that. The key to use for encryption is the last one. The key for decryption can be selected. Now, and we'll talk about how this all happens. So we drop back down. Actually, let's come back over to change. We have set new key. This key is added to the list of keys. And then this encryptor export keys, we get a list of all of the keys in a string, a new line separated string. So answer A here is the new key is stored alongside the old keys. We should mark that as correct. So that answer A is correct. Let's move on to the next one. The developer has to run a command to update all customer password hashes. Well, let's take a look as far as how this actually works. I am in the process of saving a new customer, and you can see how this works. And by the way, Joseph123, for all of you really good internet sleuths out there, this password is only used in my development environment here. And 1Password is a great feature, so don't expect to find Joseph123 anywhere online used for any of my accounts. So this encryptor get hash, we're passing in 2 parameters, the password and salt is true. Now, how does that work out in this here? Our password is passed in, our salt, and if there's no version, we come to the latest version, which is then possibly swapped out. If there is no salt, it pulls the hash. Now, we are passing in true for salt, so that this would not actually run, but you will see that the crypt key can be used for the salt. Now remember, hashing is one way. It basically takes the password and hashes it one direction. It cannot be reversed in theory. So then the hash is saved, or the salt is saved to basically help with that one-way conversion. It's like a password that's used to convert it one way into this final hash. So if the salt is set to false, i.e. we load the encryption key from our env.php, what actually happens then is the value is the salt is permanently attached with the password. So even if the original value changes again, it's not going to affect anything down the road, and it's literally just used as a to generate a hash. So, or to generate a salt, which is kind of obfuscated at that point. So at the end of the day, we have, when creating a password, with the salt is set to true, and it just creates a random string for the salt. Nothing past that. Then the hash is created with the salt being passed in. And at the end here, we have three values here: the hash, salt, and the version that are separated by a colon. So in no way here is the crypt key being used to in a customer hash, creating a customer password hash. So that means that B is false. There is ways to change this hash algorithm. There is in that process, but not actually the hash. The encryption key has nothing to do with the salt. Basically nothing to do with the salt. So that means that B is incorrect. It would not be selected. Now, here's another one. Store configuration values are re-encrypted with the new key. Ben Williamson in the comments on LinkedIn called out a good point that this is mostly correct. However, there are some bugs or some ways that we could miss out on this process if we're not careful. And this is one of those little gotchas that we build something and then we come back later. It's like, what is happening? Why did this break? Well, IT created a new encryption key because that's what their protocol said, and then this broke down the road. As such, we have, let's take a look at what is happening for this. Re-encrypt credit card numbers. I'm not even going to bother clicking to that. This line should honestly be deleted, just like that, right there. It's not, but well, oh well. So let's take a look at what happens here. Re-encrypt system configuration values. It looks for all store config types that have a backend model set to encrypted. Now, this is a big deal. In other words, this is not checking instance of. This is checking if it's encrypted, if it is the encrypted class. So if you can't extend to this class, it would break. It's walking through all the data. And what I find interesting here is this is only loaded from core config data. It is not affecting what is found in app etc config. Now, remember, we have not actually delved into the encryption and decryption process yet, and I would like to do that here quickly just to help you understand what is happening. So we come into our encrypt. What happens is it encrypts it. But we save the key version and the encryption type, and then it's finally the encrypted information. So all three of these are then stored at all times together. Now, if we jump down to decrypt, let's see how this is utilized. So we have three parts coming into this, which would be this right here: the key version, the crypt version, and the data. All three of these are then used to then identify the decryption device with that key. So yes, app etc config.php is, or those values are not, potentially not, and there's kind of some weird stuff with how the deployment configure works in this case. Those are potentially not edited or changed, which could be a problem. But at the end of the day, because we are saving these multiple keys, then nothing should actually break at the end of the day. So we have the crypt machine, and then we decrypt this value, and we see the base64 decode as well. So then we come back up here to back over to change. Then we see a writer save config. It tries to save this out, and again, kind of tying into our last answer here. We have our last answer being all caches must be flushed immediately after such a change. The key point to remember here is that we have every value is set with a version number and the hash information. Then obviously there's the encrypted information. So what the problem is we have to configure. So even if a value has not been updated, an encrypted value has not been updated, it's still able to be decrypted because we have those keys still saved in the system. So at the end of the day, caches do not have to be flushed immediately after such a change. So ultimately, the true correct answers are, in my observation, are A and C. There's obviously some caveats. This is Magento, folks, and it doesn't always work as we wish it would. And it's just kind of how it is. So at the end of the day, this is Magento, and the answers that I would select are A and C. I hope you have an absolutely wonderful day, and hope this deep dive here on encryption keys was very helpful for you. Keep up the good work.